Okay, in this lecture video, now that you've already read a little bit about periodic table trends in atomic radiuses, or radii, we're now going to look at the periodic trend in ionic radii. So first of all, let's take a look at cations. So cations tend to be smaller than their original parent atom that they were made from. Because if you think about it, if you're losing electrons from the valence shell, so that you're left with an inner level shell that becomes the complete valence shell, you removed that outermost energy level of electrons. So for example, if we take our sodium atom, that's not a very good sphere, we know that the radius, which would be from the center of the nucleus out to the outermost region of where those highest valence electrons could be, that's energy level n equals 3 if you look at the electron configuration of sodium. However, when sodium loses an electron to become the sodium ion, now that radius only goes out from the center of the nucleus, and the new valence is n equals 2. So we've gone from 1s2, 2s2, 2p6, 3s1 to an electron configuration of 1s2, 2s2, 2p6. That 3s1 electron, we can just write 3s0, is gone now. So since energy level 3 is no longer occupied by any electrons, our cation is smaller than the parent atom of sodium that it was made from. Anions, on the other hand, are going to be larger than the parent atom that they were made from. And the reason why that is because when we're adding electrons to that valence shell to complete it and make it full, usually at 8 when we're talking about S and P sublevels, we now have more negatively charged electrons in close proximity to one another. And those electrons, because they have the same charge, are going to repel each other. So if we take our chlorine atom, which is 1s2, 2s2, 2p6, 3s2, 3p5. In this outermost valence shell, we've got 7 electrons that are repulsing each other. In the chloride ion, on the other hand, we now have 1s2, 2s2, 2p6, 3s2. And since we have a charge of -1, we've added 1 electron to that last p subshell to get 3p6. That's 8 valence electrons to repulse each other. And as those negative charges repulse each other, just like a magnet, they're pushing each other farther apart. And that gives us a larger overall size for anions compared to the parent atom made from. So if I sketch my periodic table here, which is a very rough sketch, obviously. So here's my periodic table. And I want to look at trends in ionic radius. Then going from left to right on the periodic table, we see a decrease in ionic radius, so ions are getting smaller. And as we go down the periodic table, ionic radii are getting bigger. So to think about why this is, as we move down the periodic table, we're going from period to period, and we know each one of these periods is representative of an energy level. So energy level 1, the next row is energy level 2, the next row is energy level 3. So as we go down the periodic table, the electrons are in a higher energy level, at least the valence ones are. And we know that the higher the energy level, the farthest those electrons are from the nucleus. So as we go down the periodic table, even when it's an ion, the radius is getting larger. As we go from left to right on the periodic table, We also know we are increasing the atomic number. So as we go from left to right, we are increasing the number of protons in the nucleus. So you can imagine that the more protons you have, the more positive charge you have to pull those negatively charged electrons in closer to the nucleus. So as you move from left to right across the periodic table, more protons, I had to tell my dog to stop barking. So more protons are pulling those electrons closer to the nucleus, and you get a smaller radius going from left to right across the periodic table. So then we could do an example problem. Let's look at 3 different ions. We could take Na plus, F minus, and Mg plus 2. And if you write out electron configurations for those, you will get that they are all 1s2, 2s2, 2p6. So they all have a total of 10 electrons. And we call this isoelectronic when they have the same number of electrons. Then if you want to write them, so I'll write the answer here and you can go back and look at the periodic table we just sketched out. You should come up with the fact that of these 3 ions, F minus is the biggest, followed by Na plus 1, followed by Mg plus 2 as the smallest.